Welcome to the webinar regarding new guidance on product family adoption for radiation sterilization, talking about AAMI TIR35 2016. My name is Martil Winters. I'm a Director of Scientific Competency here at Nelson Laboratories, and also presenting will be Wendy Wangsgaard, PhD, Senior Scientist here at Nelson Labs. We're going to start off today going through the typical requirements for family grouping that are provided in the Radiation Standard 11137-2 2013 and in Clause 4. So we'll review those typical requirements to make sure that we're all on the same page regarding family grouping requirements, and then we'll move into the new information, the new guidance provided in TIR35. So the main purpose behind family grouping is to reduce the amount of testing that's required on a regular basis. If you have a number of products that are very similar in size, shape, manufacturing, etc., there really is no need to have to perform radiation validation work as well as routine dose audits on a regular basis when they are so similar. So the important thing to know is that family grouping is based largely on the numbers and types of microorganisms on the product. There is little to no correlation for radiation family grouping to things like density, size, and shape, although those might play a role in bioburden numbers and types, but the primary focus is on bioburden numbers and types. Now, there is a term that is similar to family grouping that's called processing category, and that is a term that they use in radiation facilities to group different products from different manufacturers together for radiation processing. But when it comes time, when we're discussing the idea of setting and maintaining radiation doses, the term family grouping is appropriate. So generally speaking, the critical thing about family grouping is that if you have a bunch of products in a family, that if there is something that causes a change to one of the products in the family, then you should see that same change in all the products in that family. So that there's kind of a bioburden connection that needs to be in place with all those products. The example you see here, you have a lovely family picture there with a husband and wife and 4 children. That happens to be my family. And that is our product family. So you see at the top, we have a wonderful picture of Wendy. And Wendy probably could be part of that same family due to similarities in cleanliness regarding product bioburden, you might say. You see the monkeys over there on the right. So not very likely, even though some of the shape might look the same, obviously the bioburden is likely going to be different because of significant differences in hygiene, to name one of a few things. And when you see the cat down at the bottom, not only is the bioburden likely to be different, but even the configuration, the shape, size, etc., is also different. And family grouping for medical products is not very different from this type of situation. We want to see that there's a similarity in the bioburden numbers and types, which will trace back to things such as handling, cleaning, storage practices, and things like that. Step 1 in establishing a new family is to first look at the information on paper. And all this information is provided in the radiation standard that I referenced on that previous slide. It gives us bullet point lists. These are all things that can impact product bioburden. So that list, raw materials, components, product design and size, etc., the focus is not so much on the subtle differences between those things in and of themselves, but more the focus is how will the differences in, for example, manufacturing process, how will that correlate to potential changes in product bioburden, both in numbers and the types. So you see that this requires someone with some microbiology knowledge to be able to do this appropriately. And in standards, we're starting to include terms such as a knowledgeable microbiologist or sterilization specialist, things like that, to point out the importance of having someone with a background knowledge in microbiology and sterilization involved in this process. Step 2, as long as it looks good on paper, then step 2 is to gather some data. And you're usually testing all the products or most of the products in the proposed family. Like we said, you're looking at both numbers of microorganisms and types, and we'll go into that in just a little bit. You see that you will know that you're not going to see the exact same counts and types of microorganisms on the various products. That just does not happen in real life. What we're looking for are general trends. So by trends in bioburden counts, you'll see a few options here. So for example, you have the bioburden counts where the counts are the same or similar. In that top box there, you see counts of 25, 21, and 29 CFU. And in this example, we're assuming those are averages of probably a bioburden test of 10 of each of those three product types. So we have a range of 21 to 29 CFU. Numerically, 29 looks higher, but really those numbers are all the same in the world of microbiology. So in that case, we would say we would consider the equivalent product approach for family grouping. Now, you might see a situation where the counts on some or maybe one of them is higher. The next example down, you see a 1521 and a 127. Now, on the first page where we talked about about documenting on paper why they should be the same, there should be a documented reason for why that 127 is higher. And if it's higher in counts, but if it has the same general types, and if there's a reason for it, for example, maybe that's the largest product, or maybe that's one product that has a little more handling or an additional component. So if there's a reason why that should be higher and why it still should be part of the family, then you consider the master product approach, and then that's the sample that you would use for determining dose and for routine monitoring. Now, looking at bioburden types, what we're really looking at here is not so much how many are orange or yellow or how many are raised or wrinkled, or what we're looking at more here is the general source of contamination. For example, how many of these are likely more human contaminants, or how many environmental or other. And this slide gives a general idea regarding where where the different microorganism types might come from. These are based off of a gram stain. And a gram stain is a very simple, fast, and inexpensive means of getting a general idea of where your bioburden may be coming from. Now, if you have bioburden names, if you've actually identified the microorganisms, then that will be even better information. But with a minimal information of gram stain, you can get a general idea of the source of contamination. For example, gram-negative rods tend to come from water. That means there's a water source there somewhere. Gram-positive cocci tend to come from people, and gram-positive rods and molds and yeasts tend to come from the environment. So generally, as you're looking at information, you can use this approach to understand the sources of contamination, because if the sources of contamination are going to be the same throughout the manufacturing process, then chances are better that the products in the proposed family indeed can be part of the same family. Now, once the data look good for putting the products together into family, then you have these three options. We talked about equivalent products already. In this case, when you're doing your initial validation work and dose audits, you can rotate through or use the same product, or you can randomly select product from the family for testing. There is no requirement regarding which one you test because they are deemed equivalent. In the master product scenario, clearly that master product is the one used for all testing. For the simulated product, sometimes we might call it a monster product. This is a case where if you have a wide variety of product types that you want to offer as part of this family, and generally the best example of this is tubing sets, where you as a manufacturer might want to have a lot of flexibility regarding how many fittings or how long of the tubing you put on, or how many different types of fittings or tubing, and because your customers might want a large variety of those options. In that situation, then for determining dose and for routine dose audits, then you could create this simulated product, which includes all the aspects of different types of tests or product types that you'll want to include in the product family, and then use that for all testing. So frequently asked questions. So the first is, do all the product components have to be identical? If we look back at, again, the focus being on product bioburden, not so much on how it looks or the supplier or things like that. So as long as you are properly screening your suppliers and have good controls in place regarding how they're handling it on their end and how you're storing it on your end, then really a molded part from one supplier should be just as clean as a molded part from another supplier. And these are not assumptions you can make. These are things you have to vet by gathering information on the suppliers. But generally speaking, you want to ensure that products or components from the various suppliers are captured. But the addition of a new fitting, which is a millimeter smaller, for example, or something like that, as long as the same practices are in place, then you're in good shape. And some of these concepts we're talking about, Wendy will talk about more specifically in her part a little bit later. So so the answer then is no. All the product components do not have to be identical. You just need to have reasonable information in place and controls in place as you're putting these products together. Now here's the one downside to family grouping. The advantage is simplicity with regards to validation and routine monitoring and dose audits. The big disadvantage, of course, is if the product that is representing the family for a dose audit, if that dose audit fails, meaning if you get too many positives in your test of sterility, then the entire product family is impacted. So if product needs to go on hold, for example, while you're investigating, then the entire family is put on hold. If product needs to be augmented, if the sterilization dose needs to be augmented while you're investigating, then again the entire product family needs to be augmented for its sterilization dose. So this means be very careful in grouping products and have those potential risks in mind as you're doing it. And if you're mitigating risks by having families properly established rather than being too broad, and if you have good controls in place, then generally you will be in good shape for the life of that product. The biggest problem we see with family grouping, so Wendy and I talk to lots of people both at seminars and on site and out in industry, and the biggest problem we see with family grouping is that they've never been properly documented. They might have a one-page paper that says, well, we grouped these products together because they look the same. And but as far as documenting all the information in the standard, then that is what we see most often being the problem. So I will challenge all of you as you are listening to make a note to go back and look at your product family documentation, look at the justification, see if there's anything in place, and if not, then that is clearly a first step in ensuring that you're properly established family grouping, is that you have all the initial documentation in place. So we've had this information on family grouping that I've just gone over. We've had that in place for many years in radiation and the standards. And what we did not have for a long time was additional information on adopting new products into a family. And so you see on the screen there, it says AAMI TIR35 2006. So that was the previous version of the document, was in 2006. And then in 2016, there was a new version published of this that had the addition of product adoption information. It gives great guidance, useful to the industry. And so now I will turn the time over to Wendy Wangsgaard to cover the details in that new document.
Thank you for that background, Martel. And as he indicated, I apologize for the typo there. We are talking about the 2016 version that does have the information that I'm about to follow. And so this slide here, this is kind of a guideline for what we will be talking about, where you can potentially take a documentation adoption approach, or a bioburden adoption approach, or even a dose audit adoption approach. And so we'll talk about those three options, and then some information is also included on maintaining your family grouping. And I can tell you that this has been long waited for in the industry, and we're very, very happy because it does provide some excellent guidance for family product grouping. So The slide here starts with number 5, and that's because that's the section in the standard that starts to talk about this, and it's basically, the evaluation and methods for product adoption that you need to keep in mind based on the information that Martel has already provided. And so there are 5 main bullet points. You want to do a technical review. You want to see if you're going to have any adverse effects based on this new product you might be adopting, what product design effects need to be looked at, obviously your material and the characteristics of that material and what effect they'll have, and then also a good look at your manufacturing environment. So first, this technical review. So what you're going to do is you have a product that you might want to adopt into an existing product family that you have. So you need to take and do a comparison of what that product looks like compared to what you've already established. Now, in this document, there is a wonderful flow chart in Annex B, and it will go through all of these bullet points that I'm going to address in a more in-depth fashion. But that's a great place to start, and it will just guide you through everything that you really need to look at and have documented, as Martel indicated. Sometimes that's not done as well as it could be. So you always want to look at what adverse effects might have when you are bringing in a new product, and part of that is you've already got a sterilization dose established, and you want to make sure that this product that you want to bring in will still function in the fashion that you need it to if it's exposed to the sterilization doses that you have established. You want to make sure the integrity of the product remains the same and that it's stable. And then also if there's any biocompatibility issues. And then, you want to make sure that it can actually perform as expected if you put it through the irradiation process that you've already determined for your product family. Then you have the determination of materials and characteristics. And what you're looking for here is that if you are doing something like increasing the surface area of your product, does that potentially increase your bioburden counts? Will that additional surface area be able to be delivered to the dose that you are verifying with this experiment? And then also you want to look at the addition of new materials. Is that additional handling going to affect your bioburden? Is the addition of that density going to cause an issue with your dose delivery? So you need to take a good look at those couple of things. Then you want to look at your manufacturing characteristics. You always want to start with your source of raw materials. Are you bringing in the same materials, or are you going to an additional source? Are you making a change to the product where you might be adding materials of natural origin? That will always be an X factor. Not everything is made the same if it's of natural origin. So you want to be careful if you're bringing anything like that. And then also, again, your component suppliers. New suppliers, you might want to take a look at the raw materials before you introduce it. And then you also want to know how those components are being manufactured. If you're bringing in something new and it's a supplier you haven't worked with before, make sure you have an audit of their facility and that the components that they are supplying you meet your criteria and won't be adding bioburden. And then of great importance also is if you are adding anything to your product that might be able to support microbial growth, because as Martel indicated, what we're really focusing on here is what effects are any of these things in your process going to have on the bioburden of the product in question. And then you want to look at your manufacturing equipment and your processing. And so there are a couple of slides here that have some bullet points of what you want to take a look at. You want to look at your process flow through your manufacturing facility. You want to see how much handling of the device occurs. Are you using all the same manufacturing equipment? Maybe with this change and adding a new product, you might be moving from a manual manufacturing process to an automated assembly. That change right there could dramatically affect your bioburden because most of the bioburden we see comes from handling. And if you change that to automated, you might be reducing your bioburden. And then also the location of your manufacturing. Is it going to be in the same place? Is it going to be someplace different? Um, Documentation of those issues is greatly affected by that. And then you also want to look at washing or cleaning processes for things that come in and might be from different suppliers. If you put things through this washing or cleaning process, it could render all of the bioburden on your components equal. And so you're starting out with a level playing field. You want to look at things such as adding a step for processing. Water can be a great source of contamination, so if you are going to bring in a process that includes water, you need to determine what effect that might have on your bioburden. You also want to consider your geographical location and climate conditions. As you can imagine, as products are manufactured all over the world, you might be having something that is made in China, and what comes in on that product might be different than something that is coming, say, from Mexico or from the United States. So you need to take a look at the big picture and see what differences those locations might bring to your bioburden. And then, of course, you always want to have control over your environmental conditions when you're manufacturing a medical device. Um, that that should be data that's readily available, and you can compare it to see if something changes when you are looking at adopting this new product. And then I did mention in that previous slide that if you're going from a manual manufacturing process to an automated one, while that might reduce the handling of your device by personnel, that might add another wrinkle to the process where lubrication takes place, and sometimes that can be a contributor to bioburden. So a lot of things to keep in mind and make sure that you document all of this as you're looking at adopting a product into a family. And so now we'll talk briefly about the three types of processes you can use. The first being the document adoption that I've just gone over. And so everything in those previous slides are found in specific detail in section 5.1 of TIR35, and then once again Annex B with that flow chart. So it simply becomes just opening up and going through each of those points that are in those sections. And if you find that after you do that, that there are enough similarities, or if there are any differences, that they are insignificant, and then ultimately that this new product you're looking at is a lesser challenge to the sterilization process, you're ready to go with just a document adoption. And once again, you need to make sure that that is done with proper personnel, a sterilization specialist who can help you look at all of that, and then you're ready to move forward. This next slide here actually has an example of a product that you might consider just using the documentation approach. And in this example, you have syringes. And the only difference between these syringes is just the size. They're made in a 3 or a 5 or a 10 or a 20 ml size. And after that, it's all an automated assembly. It's all the same raw material suppliers, and it all eventually goes through the same packaging process. So you can imagine in a case like this, the only difference being the size, and if everything else is the same, that something like this would very easily fall into documentation adoption, and you could move forward. Oh dear, pardon me, I'm not sure what happened there. So the next step that you might want to take is a bioburden adoption. So in this scenario, you've gone through all of the steps mentioned for the document adoption. and you've found that everything looks pretty good, but there might be something out there that indicates that your numbers and your types of bioburden might not quite be the same. So in that case, you would want to do a test of bioburden. That's typically done on 10 samples, and then you evaluate the data and you see that the numbers and the types that you see are similar to what your product family was established with, and so then you could go ahead and just move forward after performing bioburden testing, and your product family is set to go. And the slide, once again, is an example of where you might see those type of differences. So in this case, you've got IV administration sets, but they come with different fittings. They are going through a similar assembly process, but because of those different fittings and maybe the different configurations, that you are using different raw material suppliers for some of these different sets. So that might be the trigger that, hey, the bioburden might not quite be the same. So that's when you do that bioburden testing and show that it's similar in numbers and types. And then at that point in time, you're good to move forward with your product family. So let's say that you do that bioburden testing and you're not quite sure if it's going to be the same, and so you might want to move forward with a dose audit adoption. So it follows the same steps that we've already discussed, where you start with a documentation adoption. So you get everything down on paper, you perform the bioburden steps, and then in this case, you go ahead and perform a verification dose and a test of sterility. Now, the verification dose you would use would be the same as that established for the product family that you're trying to adopt this product into. And you do your testing, and if you get that one positive out of your 10 samples tested, you meet the acceptance criteria, and you can move forward with bringing that product into your family. This is an example of a product that might fall under this dose audit category. You've got surgical handpieces, and so they're similar in appearance, but maybe one of them has more moving pieces and parts, so it's a little bit more complex. Once again, you're bringing in supplies from different raw material suppliers due to the changes or the differences you have in these handpieces, and maybe sometimes they don't function all the same. And they do go through the same packaging process, so that's in your favor, but you did the bioburden testing and you find out, it's not quite looking like what you expected to see, and you want to make sure that if it's bioburden that might be more resistant, that you go ahead and you do that verification dose testing and the test of sterility, and upon passing results, you are able to complete your product family grouping. So now you've done all your testing, and you've got your product family, and as Martel mentioned earlier, that you have 3 different approaches to product family grouping: the master product, the equivalent product, or a simulated product. So let's say, for example, you do all of this testing and you determine that this new product you're trying to adopt actually is a greater challenge to the dosing than the current product that you have. So if that's the case, then if you have not, for some reason, performed that test of sterility, you would go ahead and do that and make sure that it passes. And then you might want to consider that you're going to make this your candidate product for future testing. Another reason to consider if you might want to make it the master product for your family is if this is, the latest, greatest product that you're going to be selling more of and producing more frequently than some of the other products in your family. And you might want to consider that, and knowing that you'll have greater availability of that product for testing for subsequent dose audits. And once you do that, you just need to move forward and make sure that you are evaluating your product families on a consistent basis. So that's another section that was added to this standard. It falls under Section 6, and it's the maintenance of product families. And you need to do this at least on an annual basis. I would recommend that you do it more often than that, because if you go through a year and you've got multiple product families, you don't want to be missing anything, given that it affects all of the products in your family. So when you do this, you want to make sure that you're looking at your bioburden, making sure that it's still in a state of control. And then you also want to be doing your dose audits and looking for passing results when you do that. And once again, please make sure that every time you do this, that it is documented. Um, so when it comes to bioburden, the next couple of slides are going to talk about some of the things you want to keep in mind. As far as trending goes, you want to be looking at your routine bioburden. You want to see that your numbers and your types are consistent with what you've seen in previous dose audits. Your environmental monitoring, you want to make sure that you are in a controlled environment and that you do have control over everything that is going on in your processing. You want to have a good handle on your raw materials. If you are switching vendors during this time, or you are using multiple vendors, you might want to do some raw material bioburden testing to make sure that the incoming components aren't adding additional bioburden that you might not have seen before. And then always there are seasonal variations that can cause some issues with bioburden spikes. So at the very least, it's a good idea to do bioburden testing on a quarterly basis so you can account for those changes you might see in seasons. And then as you are looking at your bioburden data, you want to make sure during this time that you haven't seen any alert or action level excursions. And if you have, you need to make sure that you are following your proper procedures for what happens when you do potentially see excursions. And also during this time, if you come across any design changes that you're going to make to your product, and if you're doing that, are you bringing in new materials? Are you bringing in new suppliers? Have you decided that you want to make a change to your design? That design change, it might be dimensional or geometric and physical or size related. And a lot of times that might not come into play as far as changing the bioburden of your product, but it might. And then also you want to keep in mind if some of these changes might change the way that your product is able to receive a delivered dose. As we talked about before, you want to make sure that any changes you make are not going to affect your bioburden substantially. So mentioned in that previous slide were configuration changes. You also want to keep in fact if you're going to be adding additional components to your product, the addition of that could potentially increase the bioburden on your product. And then if you decide to do something like add a coating or introduce a biological material, those types of things can really have an effect on your bioburden, either from an inhibition standpoint, where you might be adding an antimicrobial coating, or if you have a biological material that is inherently higher in bioburden, you want to make sure that that still remains applicable to the product family that you've established. And then obviously, if you are doing these changes, is it going to cause any change to your manufacturing process? And if so, you need to look at that and have documentation. Some of these things that might occur is, are you adding new equipment or are you changing equipment that you're using in your manufacturing environment, and what effect that might have? We previously discussed, if you have a manual process and you convert to automation, that can change things either with a decrease in bioburden due to the automation, or the addition of a lubrication process might increase your bioburden. And then always the enhancements. What enhancements are you making, and what effect they might have on your final bioburden? Some other manufacturing changes to keep in mind, your suppliers. Once again, geographical location. For instance, maybe you have a manufacturing site already established in one area of the country and you want to open up one on the other side of the country. You might be able to put in place all of the same manufacturing equipment and the same process, but just by very nature of the change in location, that might have an effect on your bioburden. So you want to keep an eye on that. And then also, if you are expanding within your facility or you're moving where your manufacturing process is to another location in your facility, make sure you take a look at that and see what changes that might make to your processes, your environment, and your ultimate product bioburden. Some other manufacturing changes to keep in mind are the items that you actually use in your manufacturing environment. And some examples are given here, gloves, gowns, shoe covers, the type of soap. These are just examples of some things to keep in mind. Obviously, there might be more, there might be less, but you should be familiar with your processes and what changes you're bringing to them. We have seen instances before where, people have decided that they want to switch, from just having a gown that they want to go ahead and add a hood to that or a change to that, and maybe that particular gown sheds more particulates. So when you make changes like that, look at the big picture and make sure that you have good change control in place and you understand what changes in these type of things might mean to the end product. A few more things on manufacturing changes in your environment. If you do anything with your air handling, potentially your cleaning operations, are you backing off from doing it daily and only doing it weekly? Or are you increasing it as you're increasing shifts? Additional manufacturing lines. Obviously, that will bring more moving pieces and parts into your facility, and that might inherently increase the bioburden that you might see. Gowning changes, we talked about that a little bit in the previous slides. And then also new construction or renovation. Are you doing that within your facility? Is that happening just in your neighborhood? Is there new construction going on in the vicinity? Sometimes those kinds of things can have an effect, and you might not think about that immediately. But all really good guidance on things to keep in mind. And then the last thing on this slide is additional personnel. A lot of times when you start to bring more people into your clean room, you might not have taken a look at that before. And people are dirty, and they do bring some interesting dimensions if you're not used to that. So also monitor that and see if you need to maybe move to separate shifts, or you might max out at a certain number of people that you can bring into your manufacturing environment before you start to see substantial changes to your bioburden. And so, as always with any radiation sterilization dose audit that you're performing, you're going to meant to make sure that you have a review. The guidance for dose audits is actually found in ISO 11137-1 in section 12. So you want to make sure that you are following the guidance that is outlined there. Some of that might be that due to the sterilization dose that you're using and the fact that you have low bioburden, you might be needing to do additional testing. Of course, when you're putting your families together, you want to make sure that you have a rationale for why you have your product put together, why you are performing your dose audits when you are performing them, and then you always want to make sure that it's documented, and you want to do a comparison over time to make sure that nothing has changed and that your product family grouping is still relevant for the way that you have it set up. And then, of course, if during this time you've ever had an issue where The result is you've had sterility positives, and as a result of that, you've needed to augment your dose, or you've had to perform a failure investigation either because of sterility positives or bioburden excursions or exceeding your alert or action levels. Um, Remember that everything that happens to that product used in the dose audit will infect your entire product family. So you want to make sure that if any of these things happen, what impact assessment um, might fall into place based on what those results show. And then last on the list here is if by chance you do your dose audit and you do not pass, if you have not met that criteria, you need to look at reassessing your product family. And it might mean just that you need to remove that certain product from your family, or it might mean that you need to look at switching up your product family. Maybe you've made some changes and it would be beneficial to separate out your product families so that you're not having to test every individual item that you manufacture. This is good advice regardless of, whether you just have a master product or equivalent product. Always keep in mind that you want to have good change control. You want to make sure that you are evaluating all of the things that we've talked about with regard to your suppliers, your environment, your location, and if anything needs to be addressed, that you have it documented properly, and that you also bring in knowledgeable personnel if that will be of assistance to you. So that is all we have for now. Our contact information is on this last slide, so if you have any questions or you would like to have further discussion with either of us, Martel and I are always happy to be of assistance, and I hope you all have a great day. Thank you for listening.